All right, so 7.4, applying the trigonometry ratios, part 1. All right, so we are still going to be using sine, cos, and tan like we were in the last ones. But now, like I was saying before the video started, we're going to be doing Pythagorean theorem as well. And the other one that we might have to throw in every once in a while too is the idea of all the angles in a triangle adding up to, well, you guys probably remember it, adding up to 180 degrees, right? So it's pretty much those three things. We've got SOHCAHTOA, we've got Pythagorean theorem, and then all the angles add up to 180. And we're going to like use those pieces to solve some trigonometry problems now. This one should be pretty quick because actually the first two, we're just going to do questions here. So the first two, all stuff that you guys have done before. So when it says solve this triangle, what that means is figure out everything that we don't know, right? So in this case, we only know this side and this side. So we are going to have to figure out, well, this hypotenuse over here. We'll call that side length little m, right? So this is big M, right? So across from it would be little m. We're going to have to figure out angle K, and we're going to have to figure out angle N. So there's really three things we got to solve for here. Doesn't really matter which order we do it in. So let's do the hypotenuse first. So the hypotenuse of a triangle, you guys have been doing this since grade, you guys do that in grade 8? Grade 9 anyway, for sure. Yeah, so that's going to be m squared is equal to 7 squared plus 11 squared. Okay, so that will be so we get m squared is equal to 170. And then don't forget we got a square root. So square root of that, square root of that. So square root is equal to 13, and it's 13.03, yada, yada, yada. I'm going to keep that rounded to 13. So m will be 13 there. There's the first one. By the way, too, the other way, I just want to remind you guys with our radical unit that we had, right? I also could have left my answer as the square root of 170. Right? That's also true. That is still a number. And technically, this is actually a more accurate number, right? Because we're not going to get that irrational number. We're not going to get that 13 point yada, yada, yada. Okay, so that's step number 1. Now let's find the angles. So let's find angle, doesn't matter which one first. Let's find angle K. All right. So, well, SOHCAHTOA. All right. So you guys will have this written down all over your pages when you're doing them all the time from now on, really till the end of school, until the end of grade 12. But all right, so SOHCAHTOA. So we're looking for this angle, right? Now, this is what we were doing in the last 2 lessons, but let's review this. I got to figure out what my opposite and adjacent and hypotenuse are, right? So let's label them if we're looking at this angle. So I like to find my opposite first quite often because I find it easier, where it is actually the opposite of the angle, right? So the opposite side here is this one. So you can write that as the opposite. The adjacent side is the one that's beside it, right? So that's the adjacent. And then my hypotenuse is the same one. It's the same thing as it's always been, right? The hypotenuse is, you guys have been dealing with that one for a while. All right, so what do we have? We have the adjacent and we have the opposite. So according to SOHCAHTOA, I am going to use tan, right? Opposite over adjacent. So I'm going to write that out. It'll be tan of K is equal to, and then just make sure you get this in the right order, right? It's got to be opposite over adjacent. So 11 is my opposite over my adjacent, 7. Okay, now, this is where kids get them kind of mixed up a lot of times. I guess this is what tan of K is equal to, right? Tan of K is equal to the ratio of the opposite over the adjacent, right? 11 over 7. But I don't want tan of K, I want K itself, right? So I got to like untan it. I got to like unpack it. Look at this. I got to do the inverse operation to like get it out. So the way that looks is we're going to say, okay, angle K itself is equal to, and then it's tan negative 1 of 11 over 7. That's that second function on your calculator, right? Okay, so if you guys type this in, good if you type it in too, make sure you're getting the same numbers. So tan negative 1 of 11 over 7, I get 57.5 degrees. Okay, now we're going to do the exact same thing. Well, not the exact same thing, but the same thing to find angle N, right? So now we're looking at the blue one here, but just notice what happens. Now that I'm looking at this angle here, what changes is what I'm calling my adjacent and my hypotenuse, right? Because now this is my opposite, right? The opposite side there, that's the opposite. So this would be my opposite, and this would be the adjacent. Sorry, I know you guys can't be as easy as you can. But, yeah, so it's just going to switch around a little bit. So when I write this one, this is tan of N, angle N, is equal to, and then it's still opposite over adjacent, but this time instead of 11 over 7, it's going to be 7 over 11. Okay, and then same thing, I'm going to go N is equal to tan negative 1 of 7 over 11. So tan negative 1 of 7 divided by 11, we get N is equal to 32.53. All right, so just to notice too that we could have done it a different way too, because once I had solved this one and figured out that was 57.5, and I know that this angle is 90 degrees, what do they always have to, right? The triangle always has to 180. So I figured this out actually just by going 180 minus 57.5 minus 90, right? We got me the same thing there. So either way, just by the way, too, if you guys are doing this along with me and you're getting different answers, make sure you check that your calculator is in radians. If you did this and you end up getting like 2.5 or something like that, then your calculator in radians, and if you stay in the Zoom after, and I'll give you that. All right. You know what? For the sake of time, number 2 is exactly number 1. We just have to solve. Well, actually, no, it is worth doing. There is one other skill that it'll be good. All right, let's solve for side J, little j, right? And that one, we'll do that one first. All right, so if I'm looking at angle 39, then that would make this my opposite side, and this one would be my adjacent. And this one on the bottom is my hypotenuse. So the hypotenuse is always across from 90 degrees. All right, so I'm looking again at tan, right? So it's going to be tan. But now this time I know the angle, so it's going to be tan of 39 degrees is equal to, and what it actually has, it's opposite over adjacent, right? So this time, though, it's going to be 9 over J. So 9 over J. Okay, so now all I got to do here is solve for J, right? So what I'm going to do, I'm going to multiply both sides by J. So that side by J and this side by J, just to get it up in the numerator. So then, here, I'll write it once more. J times tan of 39 degrees is equal to 9. Okay, and then I just need J on its own, so I'm going to divide both sides by tan of 39 degrees. So divide by tan 39 degrees, those cancel. So J is equal to 9 divided by tan 39 is 11.1. So 11.1, and that's centimeters, right? Because this was in centimeters. Now, notice the pattern here that when you put this in your calculator, this tan 39, that one is actually tan 39, right? With tan negative 1 this time. That's always the case when you're looking for a side length. You put the number in the way it looks, right? Just tan 39. The only time you got tan negative 1 thing is if we're looking for an angle. Right? So just make sure you get those two mixed up with number 1 place or get confused. Okay, so we found now what's left? So looks like we got to find well, let's find this side. Okay. Now we have information. We do the exact same thing. We can probably do it a little bit easier here too, right? We could say, well, I know this is 39 and this is 90. Then if I say, well, okay, well, I know all of the angles, I know 180. Well, then I can say 180 minus 90, which is 90, minus 39 is equal to 51, right? So this is 51 degrees. Okay, so I found that, I found angle J as well. Now, well, just well, the Pythagorean theorem, but we can find this another way too, right? If I'm finding side G, here I'm going to clean this up a little bit. If I'm looking for side G now, no, like I said, I know this side length, so I could go a squared plus b squared equals c squared. But I actually have to round this one too, right? So it would work, and if you used all the decimals, it would help. But the other way to make sure that I'm really accurate on this is I can use my original numbers here and use SOHCAHTOA again. So I'll go SOHCAHTOA. And this time I'm looking for G, all right? And if I'm looking at this angle, then this is the opposite side. Oops. This is the opposite side, and this is the hypotenuse. All right, so which of these deals with opposite and hypotenuse? Sine, right? So it's going to be sine of 39 degrees is equal to, and then the opposite is 9 over, and then my hypotenuse is G. And then we'll do exactly what the last one, right? We can multiply both sides by G, but I'm telling you guys last time, there's a quicker way of doing this where you can say, okay, G's on the bottom of this side. All right, well, we'll move to the top of that side, and sine 39 comes down. So I'm just going to make that switch, right? You guys will start getting good at doing that yet. Where you just move the G up, move the sine 39 down. So we've got G is equal to 9 over sine 39 degrees. And there we get 9 divided by sine 39. And we get G is equal to 14.3. That was centimeters. All right. So it says for the hexagon, calculate the perimeter length. So this is all the way around the outside and the area. All right. It's like a little puzzle, right? But so what I think on these ones, what I like to do is when you get a shape like this, it could be a hexagon or an octagon or anything, split this thing down the middle, like from end to end, like that, both ways, right? Maybe I'll make this one green too, just like that. Okay. So now what we're after here, we want to figure out, really, I want to figure out one of these lengths, right? Because that'll be easy. Once I figure out that length, I just need to multiply it by the number of sides, right? So I just need to multiply by 6 in this case. All right, so how am I going to figure that out? So I did that, and I know the whole thing is 6, right? So that would make the length from here to here 3. Oh, I get that extra. All right, back. Okay, so that'll make that length 3. And then what we're going to do, we're going to make a dotted line, or like a line right there. All right, now when I drew that line from the center to the end there, look what I made. I made a right angle triangle to that. All right, so what I'm actually after, because what if I found this side right there? What if I found from here to here? Well, what that would do, I could multiply that by 2, and then I'd have the whole thing, right? And then you'd be pretty much there to multiply that by 6. So it's set up right, but if I want to find this length x, well, we need 2 things, right? And I'm going to need this hypotenuse of 3. But I need something else here. I'm missing something. And here's where we can figure this out. How many degrees are there in a circle, right? And what I mean is if I drew a circle from like here all the way around, right, from one side to the other, that's 360 degrees, right? That's all the way around. That's 360 degrees. And then how many triangles are in there, right? Well, there's 6. There's 1, 2, 3, 4, 5, 6. There's those green triangles, right? Okay, well, if I go 360 divided by 6, right? 360 divided by 6, that should tell me what the angle is on one of these guys, right? From there to there. Well, that's 60, right? That's 60 degrees from there to there. And there, maybe I'll draw that over here so I can run the other one. That's 60 degrees, each one of them. Okay, well, when I drew that blue line in there and I split it in half, well, that was 60 degrees divided by 2, right? So that would make this angle from here to here 30 degrees. And now I have enough information. It got a little messy there, but maybe I can even draw it again. We have a triangle there now, right? This triangle in there, where I'm solving for x. I have a hypotenuse of 3, and the angle is 30. So let's do SOHCAHTOA to find x. SOHCAHTOA. If I'm looking at the angle 30, that would make this my opposite side, and this my hypotenuse. What do you deal with opposite and hypotenuse? That's sine. So we're going to say sine of 30 degrees is equal to, the opposite is x, and the adjacent, sorry, and the hypotenuse is 3. So I'm going to multiply both sides by 3, or just bring the 3 up, right? You can do that pretty easy. So again, that's just going to be 3 times sine 30 degrees is equal to x. So 3 times sine 30 is equal to 1.5. All right, 1.5 is equal to x. All right, so now we're looking at, right? I think we can do this. So if this is 1.5, then the whole top here would be 3. So you go 1.5 times 2, there's 2, is equal to 3, and that gets me the whole top. And then 3 times number of sides, right? There's 6 sides. Then I'll just say 3 times 6 is equal to 18. So the perimeter of this guy is 18 feet. We're doing a feet there. All right, so that's your perimeter. So now, here's our next problem. Now we're in an awkward place. Hopefully you were smarter than me. All right, go here now. So now we're going to find the area of this guy. So to find the area, it's a little bit messy again, but the area of a triangle, we all, I'm going to redraw just this top triangle here, right? And I knew this was 3, and we actually know what the base of this triangle is now, right? And if we find this triangle from there to there, the area of it, and again, because we multiply that by 6, there'll be 6 of those, right? But now, the area of a triangle, so area of a triangle, 18 maybe, is equal to 1/2 base times height. All right, so I now have my base, right? The base of this triangle, the top of that one, right? We said that was 3. Okay, so that's 3, and this is 3. Then I can't go 3 times 3, right? This 3 is my height. I actually need this height there. So what we can do again is we can do SOHCAHTOA again to figure out what the height of this guy is, right? What the height of that one is. So all right, to do that, we know that this is 30 degrees. Here, maybe I'll just draw that little triangle again by itself. This is 3. That was 30 degrees, and we're looking for this one. All right, so looking at that, this is my adjacent side. This is my hypotenuse. So according to SOHCAHTOA, then we're going with the hypotenuse and adjacent. Let's cos. So it's going to be cosine of 30 degrees is equal to, and it's adjacent over hypotenuse, so x over 3. So this will just be 3 times cos 30 is equal to x. So 3 times cos 30, we got 2.6. 2.6 is equal to x. Okay, now we're almost there. Now we just need to throw in the equation, because we just found that length up there. And the area of a triangle is 1/2 base times height. So the area will be 1/2. My base was 3, and my height was 2.6. And for your most accurate answer, right, don't put in 2.6 because I rounded that. So in my calculator, I'm going to actually go and grab like that the whole number. It was like 2.59 or the other. So if you put that in, you're going to get times. You're going to get an area of 3.9, and then that would be in the. But remember that was just the area for one of these triangles. Down this. So very last, we can multiply that by 3. So we're going to say times 3. Or not times 3, times 6. 6. Okay, so we get an area of 23.4 feet squared. That's square on. Okay, so that's the area of that day. What's just that, like using the tools that you guys have been using in the last couple of lessons now. So